So, you're a master's or a PhD student. That's a huge deal because you're making a massive shift. You're going from someone who learns knowledge to someone who actually creates it. But how does that even happen? How is new knowledge really made? Well, today we're going to pull back the curtain on the whole process and demystify the journey of academic research. Yeah, that question right there, it's pretty much at the heart of your new role. Think about it. Your undergrad years were all about absorbing what we already know. But now, your job is to step right up to the edge of what's known and push it a little further. And the tool you're going to use to do that is a deep understanding of scientific research. All right, so here's our game plan. First, we'll talk about that big mindset shift from learning to creating. Then, we'll dive into the 2 levels that all research works on and the 4 absolute pillars that make it trustworthy. After that, we'll get practical and walk through the actual steps of your research journey. And we'll wrap it all up with what is, without a doubt, the most important piece of the puzzle: ethics. Okay, let's get one thing straight right from the get-go. Academic research is not just a really, really long essay. It's a highly structured, systematic process, and it's designed for one single purpose: to create new, reliable knowledge. It's about finding out something nobody else knows and then sharing it with the world. Now, here's a concept that is absolutely fundamental, no matter what your field is. All scientific inquiry, and I mean all of it, operates on 2 different but totally interconnected levels. And once you grasp this duality, you'll really understand how science works. You know, we use the word science all the time, but at its root, it comes from the Latin word scientia, which just means knowledge. The key thing, though, is that it's not just any knowledge. It's knowledge that's been built in a very specific way, systematically, methodically, so that we can trust it, test it, and build on it. So here they are, those 2 levels in action. On one hand, you've got the theoretical level. This is the world of ideas, of big picture thinking. It's where we develop abstract concepts and build theories to explain why things are the way they are. But then you have the empirical level. This is the real world, the world of observation and measurement. It's where we take those brilliant ideas and test them against reality to see if they actually hold up. You see, the magic of science happens in the conversation between these 2 levels. Great research isn't just a smart theory or cool data, it's about rigorously connecting the 2. So how do we make sure that conversation between theory and reality is legit? How do we keep it honest? Well, that's where the 4 pillars of the scientific method come in. You can think of these as the non-negotiable rules of the game, the things that ensure your work is taken seriously by the entire scientific community. First up, and this one's the big one, is replicability. The idea is so simple, but it's incredibly powerful. It means that if another researcher follows your exact same recipe, your same methods, they should get pretty much the same result. I mean, if your amazing discovery only works on a Tuesday in your lab when the wind is blowing from the west, it's not really science, is it? Replicability is our best defense against mistakes and bias. Pillar number 2 is falsifiability. Now, this one can feel a little backwards at first. It means that for a claim to be scientific, there has to be a way to prove it wrong. For example, the statement "all swans are white" is scientific because all we need is to find one black swan, and boom, the theory is falsified. But a claim like "an invisible dragon lives in my garage" isn't scientific because there's no way to disprove it. This is a huge deal. It's what separates scientific questions from matters of faith or dogma. Third, we have precision. Look, vague ideas are the absolute enemy of good research. Your concepts have to be defined with crystal clarity. Just think about it. How could we possibly test a theory about societal happiness if we haven't precisely defined what happiness means and how we're going to measure it? If your definitions are fuzzy, it's impossible for your work to be replicatable or falsifiable. And our final pillar is parsimony, which you might know as Occam's razor. The principle is just beautiful in its simplicity. When you've got a bunch of different explanations for the same thing, the simplest one, the one that makes the fewest new assumptions, is usually the one to go with. It stops us from building these wildly complicated theories when a much simpler explanation works just fine. Okay, so we've covered the big ideas, the philosophy behind it all. Now, let's roll up our sleeves and get practical. How do you take all these principles and actually turn them into a research project? Let's walk through the journey you're about to start. This whole process, and it looks a bit different in every field, of course, but it generally follows these 5 steps. It all kicks off with identifying a problem or a really good question. From there, you become an architect. You design your method. The middle part, that's the engine room.
You go out and collect the data. Then you analyze it to see what it's telling you. And finally, the last step, which is just as important as the first, you report your results and tell everyone why they should care. Now, that first step, choosing your topic, is honestly one of the most important decisions you'll make. A truly great topic is a balancing act between these 5 things. Of course, it has to be original and important, but just as crucial is that you have to be genuinely fascinated by it. And then you have to be realistic. Do you have the skills to tackle it? And is it even possible to get the data you need? Finding that sweet spot where all 5 of these line up is the secret sauce to a great project. And please do not underestimate that point about interest. A master's or a PhD is a marathon, not a sprint. This quote just says it all perfectly. If you don't have that fire of curiosity in your belly, this long process is going to turn into a grind. And that's when the quality of your work can slip, or you might not even finish at all. So we've talked about the what, the why, and the how. But all of it, every single bit, rests on one final, absolutely non-negotiable foundation: ethics. Because without a deep, unwavering commitment to ethics, scientific research is completely worthless. I want to be crystal clear here. Ethics is not an afterthought. It's not a form you fill out at the end of your project. It is woven into the very fabric of every single stage, from the moment you come up with your idea to the way you share your findings. It's the bedrock. It's the source of all trust in science. And as a researcher, these are your core commitments. It means treating the people you collect data from with respect. It means avoiding plagiarism like the plague and citing every source meticulously. It even extends to how you publish and present your work. Doing it professionally shows respect for the entire scientific community you're now a part of. So there you have it. That's the framework. It's the toolkit for building new knowledge, from the big, abstract ideas all the way down to the ethical bedrock. The scientific method is an incredibly powerful tool. So the real question, the one I'll leave you with, is this: what are you going to build with it? What important problem will your research solve? What corner of the dark will you illuminate for the rest of us?